We learned in the previous lecture that parallel link is ideal for performing a sequence of operations on a large dataset. For smaller datasets, we can either use parallel link or the task parallel library. Now let's take a look at the word reversing program I wrote in the previous section. Word reversal is basically a single operation on a dataset with a small sequence of items, which are the individual words in the sentence. So here is the word reversal program rewritten in LINQ. Let's take a look. You can see that the code is super simple. There are no methods and no field declarations, only a main program method. The first thing I do is declare a string variable with the test sentence, which is again, the quick brown fox jumped over the lazy dog. Then it's time for a LINQ expression. I start by taking the test sentence and splitting it on whitespace characters to create a list of words. Then I use the select method to project the sequence of words into a new sequence of items. The act of projecting in LINQ is nothing more than running a task on every single item in the set. So in my case, I want to reverse the characters in the word. I can accomplish this by simply calling the reverse method. Now, this is a little bit of dark LINQ magic. A string is essentially a sequence of characters, and the string class is very helpful in that it implements a generic IEnumerable interface of type character. LINQ provides the reverse extension method, which takes any enumeration as input and returns the reversed set. So in this case, I reverse all the characters in the string, and the method returns a new character enumeration. I would like to reassemble these characters back into a string, but unfortunately the string constructor cannot handle a character enumeration as input. So I use the toArray method to convert the enumeration to a character array and feed that character array into the string constructor. So now I have the reversed word as a string. You can see here that I store the results of this entire LINQ expression in a local variable called words. This will be a generic IEnumerable interface of type string. The final step is to reassemble the words into a sentence. For this, I use the join method of the string class. The method expects two arguments: the delimiter character and an enumeration of strings. The result is an assembled sentence with all the words delimited by spaces. Now let me show you that everything works as intended. I will build the program and run it to see what happens. Here we go. And you can see that everything works as it should. Here is my test sentence with the characters in each word reversed. But now, it's time for a reality check. I am not using parallel link at all. This application is just a regular LINQ application. The entire operation of splitting the string into words, reversing each word, and reassembling the words into a sentence runs on a single thread. I am not harnessing the power of multiple processors at all. So, the next step is to turn this LINQ expression into a parallel LINQ expression. And this is incredibly easy. In fact, you can do this transformation at any point in the sequence of operations. You could run the first half of your expression as regular sequential LINQ, then execute the middle portion as parallel LINQ, and then execute the final bit as again regular LINQ. There are two methods that allow you to switch between sequential LINQ and parallel LINQ. As parallel, which switches from LINQ to parallel LINQ, and as sequential, which switches from parallel LINQ back to regular LINQ. I only have a single operation, which is the character reversal. So I need to put an asParallel method call between the split method and the select methods, like this. Now the expression is a parallel LINQ expression, and it will run on multiple threads and CPU cores. It will scale up gracefully to sentences with millions of words. Let me demonstrate that everything is still working. I will compile the program and run it again. Okay, here we go. And there's our proof. The parallel LINQ implementation of the program works like a charm. I always tell everyone to use LINQ as much as possible. The reason for this is that it makes it really easy to convert parts of your application into asynchronous code. Say you have a performance bottleneck in a section of code, and that section is already implemented as a regular sequential LINQ expression. Then you can simply add a single asParallel call to convert the entire expression into parallel LINQ, and it will run on multiple CPU cores and threads. However, a word of warning. Parallel LINQ will always decide for itself if it's going to run a query in parallel or sequentially. The choice depends on the size of the dataset and the complexity of the operations to perform on each item. My test application, where I reverse 9 words in a test sentence, will always run sequentially. And this is because the overhead of creating the task network, mapping the data and assigning it to individual tasks, and then reducing the result, takes so much time that it would actually slow down the performance instead of increasing it. If you want to overrule Parallel LINQ's built-in query planner, then you can actually force it to always execute a query in parallel mode. The method withExecutionMode lets you specify the desired execution mode. Default, which lets Parallel LINQ decide on its own whether to execute a query in parallel or sequentially. Or force parallelism, which will always execute the query in parallel. So let me modify the program to actually run the word reversal in parallel. All I need to do is add the withExecutionMode method right after the asParallel method, and then specify the force parallelism execution mode, like this. Now let me rebuild the program and run it again. Okay, here we go. And here are the results. Now the expression runs in parallel on multiple threads and CPU cores. Okay, so what have we learned in this lecture? Parallel LINQ is ideal for performing a sequence of operations on a large dataset, but you can also use it for small datasets. You can parallelize any LINQ expression with the asParallel method and restore it to sequential mode with the asSequential method. Parallel LINQ decides whether or not to parallelize a query, but you can force it to always parallelize a query with the withExecutionMode method.